So this section 2.5, we're not going to do any notes to it. We're just going to jump right in and do the assignment, right? Why is that? Because I think we all know how to plot points, and we could just talk about the vocab words in this section, which is correlation. And pretty much there's positive correlation if there's a positive slope, and a negative correlation if there's a negative slope. And we'll get to that right now when we work these problems out. So let's take a look at number 1 right here. They give you an input-output table, an XY table. And it's important to know that the X are the inputs, as a review. The Y's are the outputs. It's also good to know that the inputs are also known as the X values. They're also known as your domain values. So I guess we could call this like mini notes for this section. And the outputs are also known as the range values. We'll be using those words in future sections this week. Anyway, the first thing they ask you to do is to make a scatter plot. Okay, so let's take these coordinates and let's graph them. Okay, so we have the coordinate 1, 1 right here. 1, 1 is going to be, now notice that the y-axis is not going by ones. So don't put this dot as 1, 1. It's going by threes, 3, 6, 9. So you always have to pay attention to your unit values on each of your axes. So the coordinate 1 on the x, 1 on the y is actually 1 on the x, 1 on the y would just be 1 out of the 3 up. So it'd be right here. So everybody plot that point right there. That's one coordinate. And then we move on to the next one. 3, 5. 1, 2, 3. Here's 3. 4, 5. Not quite 6, but 5 would be right there, almost at 6. So let's put a dot right there. Almost at 6. Let's go on to the next one. 4, 7. So we're going to go out 4 and then 7. We said 6 is here. And since it's going by threes, it's only 1/3 of the way up, not quite halfway up. So right here would be 7. So 4, 7 would be right here. Moving on to 6, 11. Yeah, this is boring. I apologize. 6, 11. 6, 11. You're at 9. 12, so you're almost at 12. You're right there 2/3 of the way up. More than halfway, but not quite to 12, so 2/3 of the way up. Next one, 7, 12. 7 on the x, 12. That one's nice. Finally, a nice y value right there, 12. 8, 15. 8, 15. Another nice one. Last one, 10, we don't know. So we can't really graph it yet. 10, we don't know where it's at. So we could, based on the data that we have here, we could predict, is it going to be somewhere down here? No, it's going to be somewhere up here, obviously, because that's where this is going. And this is where we do a line of fit. And other books call it line of best fit, okay? So what is a line of best fit? Let me actually pull up a line right here. A line. Here we go. Let's make it blue. So you have to take this line and you have to kind of pick 2 points. So like if I picked this point, here and that point there for the line to go through, notice that all the coordinates seem to be above the blue line. So that's not the line that best fits. Right? You want to pick a line that kind of, it goes through 2 points and then it kind of goes through all of them or has them divided evenly. Does that make sense? So it'd be nice if all the points went through the line perfectly. But right here, picking my first point and my last point, it gets pretty much all of them. I mean, yeah, there's like 1, 2 dots above. There's 1 dot below, but there's actually 3 dots on it. So line that best fits, right? You want to draw your line, and it's good to use a straight edge, maybe like the edge of your notebook or a ruler would be best to draw this line. But if you look at your back on the solutions, look at the solutions. What does it say? So on the back, it provides you this answer, and it says sample answer using 1, 1 and 8, 15. So on the answers, they use the coordinate 1, 1 and 8, 15. they use this coordinate right here, the first one, and that last one. And if you draw your line through there, then you'll be able to calculate the slope-intercept form equation that produces these inputs and outputs, right? And you'll be able to use that slope-intercept form equation to predict this last value. When you input 10, what do you get out? So you want to pick 2 points that make the line that best fits the coordinates that you have on your scatter plot. One other thing, correlation. Correlation's like slope. And let me ask you this. Is this a positive slope or is it a negative slope? Positive, right? So that means that it has positive correlation. So, oh man, let me, hold on a sec. Let me make this work. Okay, that way that blue line doesn't move. Okay, so let's all write down positive correlation. Positive correlation. We drew our line that best fits. And again, if you go through the first point and the last point on this situation, that line pretty much divides them perfectly in half. It goes over a lot of those points. What else do they ask us to do? Let's write a prediction equation. They would say prediction equation. Well, if we used our first point and our last point, we could use algebra to come up with the slope-intercept form equation. So let's do exactly that. What's the first thing that we could do with 2 coordinates, with algebra? What could we do with 2 coordinates? Anybody? Slope. So m equals y2 minus y1 over x2 minus x1. And we said we're using the first point 1, 1 and the second point 8, 15. So when I go for the slope formula, this is going to be my second point. So y2 is 15, y1 is 1. So y2 is 15, y1 is 1. And then x2 is 8 and x1 is 1. x2 is 8 and x1 is 1. Does that make sense? I don't know. If it's not clear, you might want to write both of these coordinates over right here on the side and then put x1, y1, x2, y2, and you use your slope formula the way we normally do. So our slope for this best fit line using the first point and the last point will be 14 over 7. And 14 divided by 7 is 2. All right, so we have a nice, beautiful slope. M equals 2. All right, so we have our slope. Now we need an equation. If I have my slope and I have a bunch of points, because that's all we have, a bunch of points, what could we do? What equation could we use? Point slope form, right? Point slope form. And since we use this first point and this second point, let's use this first point to do this point slope form, okay? You don't want to use any of these other ones because we based our line off of the first point and the last point. So you could either use this first one or the last one to write your point slope form equation. So point slope form, y minus y1 equals m parentheses x minus x1. And of course, y1 is 1. So let me start over. Y minus y1, that's 1, equals m. M happens to be 2. Open parenthesis, x minus x1, which is also 1, using that first point, 1, 1. And now all we need to do is change this point slope form to slope-intercept form. So this is the same thing that we did last week, using point slope and slope-intercept writing equations. So let's convert this to slope-intercept by distributing 2 times x is 2x, 2 times negative 1 is negative 2. Bring down the equal sign, bring down the y minus 1. Now all we need to do is get y by itself. So we're going to add 1, and our slope-intercept form equation for this blue line that best fits is y equals 2x minus 1. So this is my prediction line, okay? So there's many things to do on these 3 questions. 1 is to first plot your points. 2 is to draw your line. And if you don't pick the same points that they give you on the solutions, you might get something different. So I recommend looking at the back and seeing that they use the first point and the last point. That way, when you use the first and the last point to find your slope, you will get that same slope too. Then you're going to plug it into your point slope form. You're going to convert it to slope-intercept. And there's still one more thing to do. They want you to predict the y value when you're 10, when your x value is 10. So what do? We plug it in, right? So let's plug in 10 right in here. What's 2 times 10? 20. What's 20 minus 1? 19. So for the input 10, we're going to get the output 19. So we used our line that best fits to predict the missing value, which is going to be 19. So if you're at 10, you're going to go all the way up to 19, which is slightly off the graph. Be about right here. Okay? And that's about it. So you're going to do that same process for the next 2 problems, and we're done with 2.5. We didn't really learn anything new. We already knew how to plot points. We already knew how to write equations given 2 points. You find the slope, you use the point-slope form, then you convert it to slope-intercept. And we already know how to do an input of 10 and get the output. Just plug it in and do the math. So we didn't learn anything new on 2.5, and that's why we just covered it right now in 10 minutes. Right now, let's jump to number 2. So we have these XY values, and they also give us this graph paper. So we're going to plot the point 5, 9. Again, be careful with the units that they use on the x-axis and the units that they use on the y-axis because they're not drawn to scale. In other words, look, right here it's going by 5s, and up here it's going by 8s, right? So 5, 9, 5 on the x, 9 is going to be just slightly more than 8, like it's going to practically be touching, but put it right there, slightly above, okay? And then let's go to the next coordinate, 10, 17. So you're going to go 10 on the x and 17 slightly above the 16, right? Like practically touching, just slightly above it. And then we go to the next one, 20, 22, 20 on the x, 22 on the y. Okay, so 22 is pretty close to 24. Definitely way more than halfway, but not actually at 24. 22 is a little bit less than 24, so plot it right there. The next one, 25, 30. 25 up to 30. Where's 30 at? It's not quite 32. It's below 32. Then we go to 35, 38. So go 35, 38. 38's not quite 40. It's below 40, but it's almost at 40. Right there. And we go 40, 44, 40, 44. So this one is right on the edge. It is going by 4, so it would go right to the edge. No, not by 4, I'm sorry. By 8, so it'd be halfway. Since it's going by 8, halfway up would be right here. 40, 44 would be right in the middle. I apologize. Anyways, we have these points. That's called a scatter plot. And now we need to draw a line that best fits. So I'm going to draw it in blue. What you need to do is pick 2 points and see which would be the best fit line. So if I were to pick these 2 points, that would be a bad idea. Because you see how that blue line doesn't go through the middle of all those red dots, right? So you're not going to use the first point and the last point. Now, what if we use the first point and the third point? Would that be a good one? Kind of. Now, why do I say kind of? Because the dots are all above it, right? So there might be some better ones. Let's use the first one and maybe the first one and the last one are pretty good. Or the first one and that second to last one. So they do use the first one and the last one because those are nice points, because when you draw your blue line right through those points, it hits the majority of the dots, or at least it kind of splits them in half, as opposed to the other ones. So on your answer in the back, it says sample using the coordinate 5, 9 and 40, 44, right? That doesn't mean that you're always going to use the first and the last one. It all depends. But you would not use the first 2 because that would produce a line that's up here. It's away from these coordinates. So this is what we call graphing a line that best fits. So we did use the first one and the last one. So how about this? Let's all circle the first coordinate. and the last coordinate. And even if you want, you could label this x1, y1, x2, y2. All right? We need to produce a prediction line, a prediction equation. All right? So we need to create an equation in slope-intercept form that will allow us to make predictions. Now, what do I mean by a prediction? You see this last one, it says 50 and then question mark. So if I go out to 50, where's my y value going to be at? Well, it's going to be somewhere up here, right? But you can't just say somewhere up here. You want a good prediction. And in order to get a good prediction, you have to make your prediction line your equation for that blue line that best fits. Now, since we use this point and this point, let's create the equation using these 2 points. So what's the only thing we could do with 2 points? Slope, correct? So, whoops. Let me go over here. I might as well use a slope formula right here on the side. M equals y2 minus y1 over x2 minus x1. So y2 is 44. Whoops, I should probably do this first. And y1 is 9. And then x2 is 40. And x1 is 5. So when we do this math, 35 over 35. And that works out beautifully because our m value equals 1. Okay. Now, if you didn't happen to pick the first and the last coordinate, if you pick different ones, you might not get the same exact line that best fits, which would not give you the same exact equation that we're producing here, which wouldn't give you the same slope. But anyways, using the coordinates that we selected, we now know the slope. Now, I need to create an equation. So which form would be best to use? Point slope. Why? Because we have a slope and we definitely have some points. And we might as well use this one because it's labeled x1, y1. So let's use point slope form. Let me do it right here on the side. Point slope form is y minus y1 equals m parentheses x minus x1. And when you use it, it's getting ugly here, sorry. When you use it, use blank spots. Y minus y1 equals m parentheses x minus x1. So our y1 value is 9. Our m value, we said, was 1. Our x1 value is 5. So here's our equation. And to get it in y equals mx plus b, all we do is distribute the 1, which is not going to change anything. It's simply going to be x minus 5. Bring down the equal sign, bring down y minus 9. Add 9 to both sides. And you'll have y equals x plus 4. So this is our prediction equation, right? This is our equation that represents that blue line that best fits. And now we could use this prediction equation to find out the prediction, my output, when I input 50. So when I input 50, what's my output going to be? 54. Cool? Why? Because remember, your inputs are your x values, which are also your domain. So you're going to input the 50 into the x because inputs are x values. And then 50 plus 4, that's 54. That gives you your y value, which is the output, which is the range. So when you input 50, you get out of 54. I mean, if you want to show the work, go for it. Y equals input 50 plus 4. Y equals 54. But that's where we get the answer that belongs in here, 54. Okay. So that's why I didn't create a whole new set of notes, because we already know how to plot points. We already know, the only new thing that we learned was the line that best fits. You got to pick 2 points that give you a nice line that represents the majority of your coordinates. All right. And then after that, we could use those 2 points to find the slope, plug it into point slope form, change it to slope-intercept form, then you could predict any value you want. You could plug in any value you want and pull out any answer you want. Oh yeah, there's one thing that I missed. Correlation. Correlation is just, is there positive correlation? Is there negative correlation? And correlation is like slope, okay? We're not even going to talk about strong correlation or weak correlation, but is this a positive slope or a negative slope? Positive, so there's positive correlation. So you could write that down, positive correlation. And that's about it. I'll explain number 3 with a different class, but you guys should already have enough to know how to do the previous one and the last one. Let's graph these coordinates on number 3. So when you graph, be careful because, again, the units aren't always to scale, right? Right here it's going by 1, 2, 3, 4, 5. It's going by 1 unit. Right here it's going by 6 units. So when you go to the coordinate 116, you go 1 on the x, and you go 16 on the y, which is almost to 18, but not quite. So it's not in the middle either. It's just almost to 18 right there. So everybody please place that dot. Now let's go to 216 also. 216 is at the same y value 16, same height. Now let's go to this next one, 3 question mark. We can't graph that. We're missing the y value, and we'll find that missing y value once we make a line that best fits. All right, so then we move on to the next available coordinate, 4, 22. So you go 4, 1, 2, 3, 4, 22. It's 22 is almost to 24, but not quite. So we're going to put it a little bit closer to the 24 than the middle. So here we go, about right there. Now let's go to the next one, 5, 30. 5 and then up to 30. 30 is a nice one because it's actually there. Moving on, 7, 34. 7, 34 is almost to 36, but not quite. And then 8, 36, the last one, 8, 36. 8 on the x, 36 on the y, which is right there. Okay, so we have these points. This is called the scatter plot. And you need to get the line that best fits. So you want to pick 2 points and draw a line through it and see, well, don't draw a line through it, but maybe with your pencil, put your pencil through 2 points. Imagine this. So get your pencil and just take that pencil and make it go through 2 points so you could make a line that best fits the coordinates that are there. Now, if you use the first and the second point, that would be a horrible line, right? Because this line is not representing the line that best fits of all these coordinates. So the line has to go, your pencil has to go, maybe you want to pick the first coordinate and the last coordinate. That'd be kind of good. It's kind of hard to see with the pencil. Let me actually draw it or get an actual line here. Okay, so it would be bad to use the first 2 coordinates because that would be a flat line. Maybe the first coordinate and the second to last coordinate. See, I'm picking this point or the last point. That'd be a good one. Or perhaps maybe the first coordinate and the second to last coordinate. But anyways, we need to pick 2 points. Okay, so on the back, they say that their sample is from the second coordinate to the second to last coordinate. But the thing is, you want to pick a line that represents all of the majority of your coordinates, and this would be a good one. This point and this point over here. Okay, so second and second to last. So we use this one right here, and second to last, this one down here. Okay, so when we have those 2 coordinates, when we have those 2 coordinates, we'll be able to find the exact slope using the second point and the second to last point. So let's do that. M equals y2 minus y1 over x2 minus x1. And if you're wondering, well, if you're using the second point, we're going to call that the first point that we're using, x1, y1. And the second to last, we'll call that x2, y2. All right, so we're going to go y2 minus y1, which is 34, minus 16. And then over x2, 7, minus x1, which is 2. And that's specifically using the second point and the second to last point. When we go 34, take away 16, we get 18 up on top, and on the bottom, it's 5. So our slope, m equals 18 over 5. That's our slope. And now we have a slope, and we obviously have a bunch of points. So what form would be good to use? Point slope, right? So point slope, we're going to go with the first coordinate that we actually used on the slope, the x1, y1. So let's write point slope form. There's point slope form, y minus y1 equals m parentheses x minus x1. And let's rewrite it with blank spots. And then we'll plug in our values. Our y1 value is 16. Our m value is a disgusting 18 over 5. And our x1 value is 2. So that's our point slope form equation, and let's get it to slope-intercept form. To get it to slope-intercept form, we'd have to distribute 18/5 times x. That's simply 18/5 x. And then 18/5 times -2. It's going to be a negative. Just put the 2 over a 1 and multiply the top with the top and the bottom with the bottom. You'll get 36/5. That's an ugly one. And then equals y minus 16 on this side. Y minus 16 on this side. Now, if you want to temporarily get rid of all fractions, you could multiply everything by 5. And if you multiply everything by 5, you'll have 5y equals 80. No, I'm sorry, 5y not equals. 5y minus 80, because 16 times 5 is 80, equals 18x minus 36. I multiplied everything by 5 just to temporarily get rid of the fractions over 5. And now let's get y by itself. So you'd go plus 80. My new equation would be 5y, let me write it over here, 5y equals 18x with positive 44. Final step would be to divide by 5, divide by 5, divide by 5. So there's my slope-intercept form equation. 5y, I'm sorry, not 5y, equals 18 over 5x plus 44 over 5. On the solutions, they don't have them as fractions, they have them as decimals. So let me rewrite it the way they have it in the back. Y equals 3.6 x plus 8.8. Okay. So this is your equation of that blue line that best fits the scatter plot that we did. Now, this is what we call a prediction line. This prediction line will help us predict any missing values. So if we go back up here and we look at this missing value, the input 3, it's going to give us a certain output. Now we could visually see it over here that when you input 3, you're going to get somewhere in between 18 and 24, a little bit closer to 18 than 24. But if you want an exact value according to our prediction, you just plug in the value of 3 for x. So you'd have y equals 3.6 times 3 plus 8.8. And of course, do it with the calculator, and you should get 10 point, I don't know. So y equals 19.6. So that missing value that we had up here, that's almost 20. 19.6 is good. Also, one last thing, but the one final thing I want to talk about is correlation. As I've mentioned on number 1 and 2, correlation is just, we're not even talking about the strength of the correlation. If the correlation is strong, most of the scatter plot ends up pretty tight, close to your line. If it's weak, the scatter would be more further away from the line. But right here, we're just talking about positive or negative correlation, and that's exactly like the slope. If from left to right, it's going up, that's going to be a positive correlation, just like a positive slope. If from left to right, it's going down, that's a negative correlation, just like slope, it's negative. So this is going to be positive correlation. And you could check the answer on the back. It does say positive correlation. This is a half-hour video. I apologize, but it's all there explaining every single question 1 through 3 with all the details.